Today we're going to talk about solving polynomial equations. The essential question for today is, how can you determine whether a polynomial equation has a repeated solution? So example 1 says solve 5x cubed minus 40x squared plus 80x. Okay, up until now all we could do is factor, so that's what we're going to do to start with. So we're going to factor out the greatest common factor, which is 5x. Once we factor out the 5x, we're left with x squared minus 8x plus 16 equals 0. Now, we're not quite done factoring. Remember that when you're solving, it does have to equal 0 before you start. So I factored x squared minus 8x plus 16, which breaks down to x minus 4 and x minus 4. Now all we do is, if you remember back to when we were solving by factoring, all you do is set each factor equal to 0 and solve. So I set 5x equal to 0 and solve, and I got 0. I set x minus 4 equal to 0, I got 4. I set x minus 4 equal to 0, I got 4. So what we can say is the solutions are x equals 0, and 4 has a multiplicity of 2, which means it occurs twice. Now in the online assignment today, you will not list the 4 twice, you'll just list it once, kind of jumping ahead, talking about multiplicity. So since we only have 2 different answers, those are the answers we list. Now if we look at the graph of it, it looks something like this. It did have an intercept of 0. Since my degree was odd to start with and my leading coefficient was positive, it should go down, then up, which it does. At 4 is my other intercept, which is fine. And we talked about if an intercept occurs twice, it tends to bounce. So that's why here it bounces. Let's look at another example. Example 2. Find the zeros of f of x equals x to the 4th minus 18x squared plus 81. Okay, step 1, set it equal to 0. Step 2, see if they have anything in common, which they don't. Step 3, factor. Well, it's the pattern of a quadratic, which is x to the 4th and then x squared. So all I did was evenly divide it up between the two. So I said x squared and x squared give me x to the 4th. I wanted negative 18x, so I used negative 9 and negative 9, and if I FOIL that back out, it does become a negative 18x squared. Next, I factored those, or you at that point could just solve them. I factored them. I got x plus 3x minus 3, x plus 3x minus 3. So if I wanted to say exactly, I would say I have negative 3 has a multiplicity of 2. And 3 has a multiplicity of 2, or basically my two intercepts are negative 3 and 3. So then what I need to do is figure out the end behavior of my graph. I also have a little extra work here I'm going to explain in a minute. So to find the end behavior, I look at my beginning function, which is x to the 4th, so that's an even power. My beginning number is a 1, so that's positive. So even positive, my graph should go up on the left and up on the right. Now, just like this x to the 4th right here, I probably need to figure out where it hits on the y-axis. So then I used substitution to evaluate, or you could use synthetic division, and I got 81 as an answer. From there, I decided to plot those points. My two x-intercepts are negative 3 and 2, positive 3. And then my y-intercept is 0, 81. If you notice, I went by 1s on my x and by 10s on my y. So now I need to sketch that graph in. So I know my graph is going to start up on the left. It's going to come down, probably hit there, because at negative 3 it had a multiplicity of 2, which means it's going to bounce. Going to come up, go back down, bounce there, and go back up. So your graph will probably be better than my sketch. So, that's a really bad sketch, but you get the idea. So yours will look more like a W. Mine looks more like something really special. So there is my graph. Let's try example 3. It says, find the zeros of x cubed plus x squared minus 6x, then sketch the graph. So step 1, just like before, I set it equal to 0. I look to see if they have anything in common, which you have an x. So then inside I have 3 terms, so I'm going to factor that. I get x plus 3 and x minus 2. So then I set each factor equal to 0. X equal to 0 is 0. X plus 3 equal to 0 is negative 3. And x minus 2 equal to 0 is 2. I might as well go ahead and take my original function up in here and substitute in 0. When I do that, I find that I have a y-intercept of 0. Okay, so I have my x-intercepts at negative 3 and 2. My y-intercept is at 0, 0. If I look at my function, the original function was a third power function, which is an odd function. My leading coefficient was positive, so it should look something like this. So I'm going to go down on the left and up on the right. So once again, you get to see my horrible sketching skills with my finger on my mouse pad. It's going to go down. It's going to come back up. Now, I didn't have any bumps in this one per se. It didn't hit and bounce off of any x-intercept because each one of the x-intercepts occurred once. So it just went through every single point. Okay. Next, what we're going to talk about is the rational root theorem. The rational root theorem will help us to divide and reduce a problem when it's not factorable. So it says you're going to take all the factors of the constant, which is the last term, over all the factors of the leading coefficient, which is the first term. So the first problem we're going to do is x cubed plus x squared minus 14x minus 24 equals 0. If it's not equal to 0, make sure it's equal to 0. Now, what I would normally do is I'd say, hey, there's 4 terms, let's factor by grouping. But unfortunately, in this case, it doesn't work because if I factor out a 2 from my second set, I still don't get the same set of parentheses for the first as the second, so I can't factor by grouping. So just like the instructions said, we're going to factor the first term only and the last term only. So 1 over 1 is 1 because it says factors of the constant. So factors of the last over factors of the first. 1 over 1 is 1, 2 over 1 is 2, 3 over 1 is 3, 4 over 1 is 4, 6 over 1 is 6, 8 over 1 is 8, 12 over 1 is 12, 24 over 1 is 24. So what happens is we create this list of possible x values or possible zeros. So all the factors of the last over all the factors of the first. Now, I did put a positive and negative in front, and theoretically it's all of them. They're all positive or negative because I don't know what the answers are. Now, the theorem states basically, if you do that and then you divide, we should get a remainder of 0 if it's an answer to the problem. So in order to deal with that, what we're going to have to literally do is we're going to pick one of these numbers at random. I kind of start here at 1 and then try -1 and then try 2 and -2. I do them systematically, but our goal is to get a remainder of 0. So I did synthetic division 3 different times using my initial 1. So 1 is your leading coefficient, 1 is your x squared value, -14 is your x, and -24. So then I did synthetic division. I divided by 1, I got a remainder of -36, which means it is not a solution. We want a remainder of 0. So then I repeated the process. This time I tried -1. So I did that and I got -10. Okay, we're getting closer there. So then I tried 2. Well, when I tried 2, I got -40 as a remainder, which means we're getting even further away. So it's probably not a positive number to start with. It's probably a negative number. So I'm going to try -2. So I tried -2 using synthetic division, and I got a remainder of 0, which means -2 is an answer to one of my problems. Now, I do have other answers, though, and here's where they come from. I know that -2 is one of the answers, so if it was in factored form, it'd be x plus 2, because if you set x plus 2 equal to 0, you get -2. Now what I'm left over with is what is in the parentheses right here, which is these terms in my reduced problem. My original problem started out as an x to the third, so this is going to become an x to the second. So we get x to the second minus 1x minus 12. That is where I got that. Now this looks like something I can factor to finish solving. So I factored x squared minus 1x minus 12, and I got x minus 4 and x plus 3. From there, I found my solutions. So I got x equals -2 and 4 and -3. Noticing here it doesn't say draw it. We could draw it. But it doesn't say we have to. It just says find all real zeros. So my answers are -2, 4, and -3. So eventually, if I would have tried like 3, I would have found -3. And then 4 would have worked. But that was getting awful big. So that is kind of why I try to switch up and use negatives sometimes. So let's try another one. Find all the real solutions of x to the third minus 5x squared minus 2x plus 4. So step 1 is it equal to 0, which it is. Step 2, I have 4 terms. Maybe I try factoring by grouping, but unfortunately I would end up with like x squared times x minus 5 minus 2 times x minus 12, which does not factor by grouping. So once again, I list all the factors of the last over all the factors of the first. So all my factors are 24. So 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 8 over 1, 12 over 1, 24 over 1. Notice I don't list them twice for that second factor of 1 because they just repeat themselves. So then I said to myself, well, there's got to be something here to help me out. There's quite a few answers. So what I did was I thought, well, you know, if they're solutions to the problem, they're x-intercepts. So maybe if I were to use Desmos or something, I could look at the graph and maybe get some ideas. Well, when I looked at the graph, it looks like it hits at -2, 3, and 4. So those are probably my possibilities or my answers. So it doesn't matter which one you pick. I just picked -2. I normally just pick the one furthest to the left if they're all integers. You can use whichever ones you want. I did synthetic division and I got 0. So now what I've done using the graph is I'm not sitting here trying synthetic division forever to find one answer that works. In this case, by using the graph to help me and I looked and found one x-intercept, then I have a problem that's a lot easier to work with. So now what I'm going to do is going to take my reduced problem here. I know that -2 is one of the x values. So in parentheses, that would be x plus 2, because remember, it's the opposite. Since I started with an x to the third, I'm going to make this an x to the second. So x to the second minus 7x plus 12. That is where my second set of parentheses came from. Then I said, oh, I have 3 terms, so I'm going to factor the second one. I got x minus 3x minus 4. Well, if I set each one of those equal to 0, I get -2, 3, and 4. And if you look, it is at -2, 3, and 4. So you could have divided by 3 first. Or you could have divided by 4 first. It doesn't matter. You'll get the same answer in the end. Now the last example I'm going to throw at you is a little more tricky. This is example 6. It's a 4th power problem, which means we have no way to factor it to begin with because they do not all have something in common. So I'm going to have to list the possibilities first. So I said the first term is 6 and the second last term is 4. So then I listed all their possibilities, 1, 2, 3, and 6. And then I did 1, 2, 2, and 4. So the rule is all the factors of the last over all the factors of the first. So I always take all the numbers over here over the first number. Some people like to do them a little bit differently, but I'll explain how they are the exact same way and you get the exact same list of possibilities. So I'm going to do 1 over 1, which is 1. 2 over 1, which is 2. 2 over 1, which is 2. I already have that listed, so I don't need to list it again. 4 over 1 is 1. Then I repeat the process. It's all the factors of the last over all the factors of the first. So I put them all over this 1. So maybe I'll mark that out. So now I need to put them all over the factor of 2. So 1 over 2 is a half. 1 over 3 is a third. Okay, and then 1 over 6 is 1/6. Or you can say 1 over 2 is a half. 2 over 2 is 1, which I already have it listed. 2 over 2 is 1, and 4 over 2 is 2. Okay, so I put them all over 2. Then I repeat the process. Now I do over 3. 1 over 3 is a third. I already have that. 2 over 3 is 2/3. I already have that. 4 over 3. So I put everything over 3. Now I put everything over 6. 1 over 6 is a 6. 2 over 6 is a third, which I already have, and 4 over 6 is 2/3. So now I put them all over 6. So it really does not matter. You can start here and put them all over 1, then all over 2, then all over 3, then all over 6. Or you could take each one of these and put them over all those denominators and then repeat the process with the other ones. So 1 over all of these, 2 over all of these, and then 4 over all of these. And reduce. And here's the list I came up with. Okay? Great. Well, let's use the trick of looking at a graph to help us. So I looked at a graph. Here's my graph. Now this one's a little bit trickier because it's got a lot of funky decimals in here. I do see a half, so that's why I picked a half to start with. That was kind of nice. I know that's a half, and I know it's in my list right here. So I did a half. I got a remainder of 0. So then I thought, well, then I could write my problem. So I could say 6x cubed minus 8x squared minus 20x minus 8. And then I could attempt a factor by grouping there. But there is something that can kind of help. Basically, when you are dividing, what it's doing is it's reducing your power each time by 1. So now that I have this problem right here, 6x cubed minus 8x squared minus 20x minus 8. What I can do is I can look over here in my graph and find another one of those answers if there's another easy one to read. Now this one says negative 0.667. Well, that means negative 0.66666, which is a repeating decimal. We know 0.6 repeating is 2/3. And my negative's up here. So then I took my answer, 6, negative 8, negative 20, and negative 8, and I divided by negative 2/3, which did work, and I got 0. So I'm great here so far. So if you look, I haven't listed all the parentheses in front, and that's fine. We're just going to wait on these because they're fractions. They can kind of be hard to deal with. So if this was x to the third, that means this is x squared. So I'm left with 6x squared minus 12x minus 12. Well, I say, oh, they're all divisible by 6. So I divide everything by 6. Now what I get is this. Now, I do not need to put the factor of 6 in front, and here's why. I'm not just factoring completely. I'm solving the math problem. So all I did was reduce the entire problem by a factor of 6. So then I said, okay, factors of negative 2, that give me negative 2. Well, there aren't any. Great. I know one answer is a half. I know one answer is negative 2/3. But more than likely, there's a couple more answers because it looks like it hits a couple more places. Okay, so I have options. I could complete the square. So move my negative 2 to the other side, add my blank, and then use my inverses to solve. Or I could use the quadratic formula. I'm just going to use the quadratic formula. Remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I substituted it into the quadratic formula. I reduced it, and this is what I got, 2 plus or minus the square root of 12 over 2. Well, I know that 12 is 4 times 3. The square root of 4 is 2. So that's 2 plus or minus 2 square roots of 3. Well, then I look and I say both my whole numbers are both divisible by 2, so I might as well divide those. So I get 1 plus or minus 1 square root of 3, or just the square root of 3. Now notice I did go ahead and bring down those other two answers that I had up here. There's one. There's the other one. Thus giving me 4 answers. 1, 2, 1 plus the square root of 3, and 1 minus the square root of 3, which is these the other two answers. Now, looking at this, how do I know it's the same? Well, if you wanted to check yourself, if you do 1 plus the square root of 3 in your calculator, you'll get this decimal right here. If you do 1 minus the square root of 3 in your calculator, you get this decimal right here. So I know I've done it correctly. So that's, in a nutshell, how to solve looking at a graph to help you out and listing the rational zeros to test. I hope this has been helpful. You have an assignment and big ideas. I will see you next time.